So this is a video to show how you could get hole detection with MLG Webcheckers. The set I have here is this the Ethernet IP setup. I've got IO link was here. I don't have these connected right now, but the data would look very similar. So the part number I have is 1106623. It has a response time of 7.1 milliseconds. The more beams you have, the slower the response time is going to be. So this one has 30 beams, so it's just a 145 millimeter stick. There's a couple different ways we can get this. This variant, I have Q1 that I can get out of the device. That would be over discrete I/O, or I could bring it over, say, Ethernet IP or Profinet over a field bus. So once I bring it over a field bus and I put my EDS file in it, I can determine which input assembly I want to use. And so you can see if I'm using 101, which is what I have in my PLC, I'm getting all of these edges, plus I'm getting the functions out of it. And then I get system status, where I can give it quality of run alarms or whatever it may be, as you see here. And then I get the digital output status. So that would be the same thing at Q1, Q2, Q3, what we'll see here in SOPUS. So these are all of those QINTs. Now, since I have 16 of them here, a whole word of data, the only one I'm going to use is Q1. So I can either bring that in the PLC over a field bus, or I can use that discrete I/O that we've got. So right now you see I've got, if I don't see, if edge 2 does not exist, then I want that signal to come on, or I can invert it and it could go the opposite direction. So right now we'll just leave that on. You'll see if I stick my finger in there, it only sees 2 edges. But if I stick 2 in there, simulating a hole, now I see 4 edges, and you see that signal, it goes low, right? So that would indicate that I've got a hole or break in it. So just to show that how it comes in the PLC, this is my edge data. So you'll see the edge data and the function 1 through 10. So this would be the edges, and then this right here is the function 1 through 10, and those are all configurable as well, depending if you want center position or width. But so we had the system status that's coming in here, and these are going to be the QINTs. So if you see I stick my finger in there, I see just 2 edges, and you see QINT1 is still high, but if I stick 2 fingers in there, you'll see it'll change. So if I want to pull that data over that bit, all I'd have to do is break that down into a bit level. And you'll see right now that's high and this is high. If I stick 1 finger in there, you'll see it stays the same. If I stick 2 in there, you see it drops and it gives a low signal, indicating that there's a break or it sees multiple edges. So that would be one way that you could get hole detection out of it, with just a discrete I/O or a single bit with your PLC. Hope this helps, and let me know if you have any questions.